December 15th, 1942, Detroit Tank Arsenal, Warren, Michigan. The metallic screech of grinding gears echoed through the cavernous factory floor as another M4A3 Sherman limped to a halt, its transmission seized beyond repair. Steam hissed from the engine compartment while oil pooled beneath the 71,024-pound behemoth, creating dark stains on the concrete that told the story of American industrial ambition colliding with mechanical reality. For the third time that week, production supervisor James Mitchell watched another wonder weapon become a 30-ton paperweight. "That's number 47 this month," muttered Sergeant Bill Henderson, wiping grease from his hands with a rag that had seen better days. The veteran tank commander had survived the scorching sands of North Africa, only to find himself battling mechanical demons in Detroit's industrial heart, where the smell of hot metal and burning oil hung thick in the December air. "At this rate, we'll lose more Shermans to transmission failure than German guns." Mitchell's jaw tightened as he surveyed the assembly line stretching into the distance like a mechanical river. 40,000 Shermans were scheduled for production, but the Ford GAA V8 engines, all 500 horsepower of aluminum fury, were overwhelming the existing transmission systems with their violent torque surges. The controlled differential couldn't handle the punishment. The Synchromesh 5-speed was failing at an alarming rate of 23% during initial testing, each failure representing $8,400 in 1942 dollars, equivalent to $147,000 today. The numbers were staggering and sobering. Every failed transmission meant another tank that couldn't reach the boys fighting in Italy, another crew that might face a Panzer IV with inferior equipment. The weight of responsibility pressed down on Mitchell's shoulders like the Michigan winter pressing against the factory's steel walls. But what nobody knew was that a soft-spoken machinist named Eugene "Red" Kowalski had been quietly documenting every failure, every seized gear, every catastrophic breakdown. Working the night shift in the transmission bay, Red had filled 3 leather-bound notebooks with precise measurements, failure patterns, and theoretical solutions that would revolutionize armored warfare. His calloused hands moved across the pages with the precision of a surgeon, recording data that would soon change the course of tank production. In the corner of Bay 7 sat Sherman Hull number 4A3-2847, officially condemned after its transmission exploded during a routine test drive on the proving grounds outside Detroit. The blast had shattered the gear housing like an eggshell, twisted the drive shaft into a pretzel, and left metal fragments embedded in the engine compartment walls like deadly confetti. The acrid smell of burned transmission fluid still lingered around the machine 3 days later. Cost to repair, $8,400 in 1942 dollars, equivalent to $147,000 today. The Army's verdict was swift and merciless: scrap metal. Strip it for parts and melt down the rest for the next batch of tanks rolling off the production line. Red Kowalski saw something different when he looked at the mechanical corpse. "Give me 2 weeks," he told Mitchell, his calloused hands already reaching for his toolbox, fingers tracing the familiar weight of wrenches and micrometers that had become extensions of his body. "I can make her run better than factory spec." Mitchell almost laughed, the sound catching in his throat like smoke. The 34-year-old Polish immigrant had worked at Ford before the war, building civilian cars that purred down peaceful streets. But fixing transmissions was one thing, reinventing them was another entirely. "Red, that tank is finished. The differential is cracked clean through, the gear train is destroyed, and the torque converter looks like it went through a blender operated by a madman." "Exactly," Red replied, his eyes gleaming with the intensity that had earned him his nickname, not for his auburn hair, but for the red-hot sparks that flew when he worked, illuminating his face in the darkness of the night shift like a welder's torch. "Which means I can start fresh, build something that actually works instead of just looks good on paper." The factory floor around them hummed with the constant rhythm of production, pneumatic hammers driving rivets, overhead cranes moving massive steel plates, the distant roar of test engines being broken in. But in Bay 7, silence hung over the condemned Sherman like a shroud. What Red understood, and what the Army engineers with their college degrees and clean fingernails had missed, was that the Sherman's transmission wasn't just failing, it was fighting itself. The Ford GAA engine produced torque in violent, unpredictable surges, like a bronco trying to throw its rider. But the transmission was designed for smooth, consistent power delivery, the kind you'd find in a Buick cruising down a Sunday drive. It was like trying to conduct a symphony orchestra with a sledgehammer. Working 18-hour shifts that blurred the line between day and night, Red began his reconstruction. The factory's skeleton crew knew him only as the crazy Pole who talked to machines, who could diagnose a transmission problem by the sound it made from 50 feet away. They watched him work with a mixture of admiration and bewilderment as he tore apart the condemned Sherman's drivetrain with surgical precision. He modified the torque converter with a series of dampening chambers, each precisely calculated to absorb and redistribute the engine's power spikes like shock absorbers on a car hitting potholes. Using salvaged parts from other condemned tanks, a planetary gear here, a clutch plate there, he created a hybrid system that combined the reliability of the original design with innovations that wouldn't be seen in civilian vehicles for another decade. The breakthrough came on December 28th, during a blizzard that had shut down most of Detroit and left the factory floor eerily quiet, except for the howling wind outside. Red was alone in the cavernous space, the only sound the rhythmic hammering of his modifications echoing off the steel rafters like a metallic heartbeat. Snow piled against the windows, creating a cocoon of isolation around his work. As he installed the final component, a custom-machined planetary gear set that he had crafted on the night-shift lathe with tolerances measured in thousandths of an inch, he realized he had solved more than just the Sherman's transmission problem. The mathematics were elegant in their simplicity. By redistributing torque loads across multiple gear trains and incorporating hydraulic dampening, he had created a system that could handle 40% more torque while reducing mechanical stress by 60%. He had created a transmission that could turn the Sherman from a mechanical liability into a mechanical marvel. January 3, 1943. The proving grounds outside Detroit were frozen solid, the ground hard as concrete beneath a blanket of snow that crunched under the treads of Red's resurrected Sherman. The temperature hovered at -15 degrees Fahrenheit, cold enough to make metal brittle and oil thick as molasses. Perfect conditions for testing the limits of mechanical engineering. "Jesus Christ," whispered Henderson as the tank accelerated smoothly through its gears. The sound completely different from the grinding, coughing wheeze of standard Shermans. It's like riding in a Cadillac instead of a farm tractor. The official test results were staggering, numbers that made hardened engineers do double takes and check their instruments. Red's transmission handled 750 horsepower, 50% more than the Ford GAA could produce, without a single failure or even a hint of strain. The gear changes were seamless, smooth as silk. The torque delivery was consistent as clockwork, and the system operated at temperatures 30 degrees cooler than standard transmissions. But the real test came when they pushed the Sherman to its limits. Where standard transmissions would overheat and seize after 30 minutes of hard driving, Red's system ran cool and smooth for 3 hours straight. Where standard systems required delicate handling and experienced drivers, Red's transmission was forgiving enough for a farm boy from Iowa to operate effectively. "How the hell did you do it?" Mitchell asked, his breath forming clouds in the frigid air as they watched the Sherman execute maneuvers that would have destroyed a standard transmission. Red just smiled, his hands already moving to check oil levels and inspect components. "I listened to what the machine was trying to tell me instead of forcing it to do what I wanted." But what nobody knew was that Red had done more than save one condemned tank. His innovations would be quietly incorporated into Sherman production, reducing transmission failures from 23% to less than 3%. Over the next 2 years, his modifications would keep an estimated 12,000 additional Shermans operational in the field, each one representing lives saved and battles won. While headlines screamed about D-Day and the liberation of Paris, a quieter war was being fought in the maintenance depots and repair facilities scattered across Europe. Tank crews who had never heard of Eugene Kowalski were discovering that their Shermans were lasting longer, running smoother, and requiring fewer repairs than the machines their predecessors had cursed and coaxed across North Africa. Staff Sergeant Tommy Morrison of the 3rd Armored Division noticed it first during the push through the Ardennes. His Sherman, manufactured in early 1943, had been running for 8 months without a single transmission failure. "This old girl purrs like a kitten," he told his crew as they rolled through the Belgian countryside, unaware that Red's innovations were keeping them alive. The statistics told the story that individual tank crews couldn't see. Before Red's breakthrough, Sherman transmission failure rate stood at 23%, with average repair time of 72 hours and a replacement cost of $8,400 per unit. After implementation of his modifications, failure rate dropped to 2.8%, repair time decreased to 18 hours, and replacement costs fell to $2,100 per unit. The strategic impact was immense, numbers that would have made generals weep with relief if they had understood their significance. Those 12,000 additional operational Shermans represented more firepower than the entire German Tiger tank production of 1,047 units. Red's condemned tank had become the prototype for a mechanical revolution that helped tip the balance of armored warfare in favor of the Allies. Red never received official recognition for his breakthrough. Military secrecy classified his modifications as proprietary manufacturing improvements, and post-war records buried his contributions in bureaucratic files that gathered dust in government warehouses. The Army brass who took credit for improved Sherman reliability had never set foot in Bay 7, never felt the bite of metal shavings or the satisfaction of a perfectly machined gear. He returned to civilian life in 1945, working at a small machine shop in Detroit's East Side until his retirement in 1978. The shop specialized in rebuilding transmissions for city buses and delivery trucks, mundane work that paid the bills but never challenged his abilities the way that condemned Sherman had. Customers knew him as a quiet man who could fix anything mechanical, who charged fair prices and delivered quality work. But tank crews across Europe unknowingly owed their lives to the soft-spoken machinist who saw potential in a condemned machine. His transmission innovations kept Shermans running through the hedgerows of Normandy, where every functioning tank meant another German strongpoint reduced to rubble. They rolled through the forests of the Ardennes during the Battle of the Bulge, where mechanical reliability often meant the difference between victory and retreat. They participated in the final push into Germany, where superior numbers and mechanical dependability overwhelmed the technically superior but mechanically fragile German armor. The impact of Red's innovations extended far beyond the immediate tactical advantages. American tank crews, confident in their equipment's reliability, fought with an aggression and boldness that German commanders found difficult to counter. When you knew your tank would start every morning and run all day without breaking down, you could take risks that crews with unreliable equipment couldn't afford. The psychological effect was equally important. Tank crews who had watched their predecessors struggle with mechanical failures now had machines they could trust. Morale improved, training became more effective, and the overall combat effectiveness of American armored units increased dramatically. German intelligence reports from late 1943 began noting the improved reliability of American armor. Enemy tanks demonstrate superior mechanical endurance, noted one Wehrmacht analysis. Maintenance requirements appear significantly reduced compared to earlier models. What they didn't know was that a single machinist in Detroit had given the Allies a decisive advantage in the war of attrition that tank warfare had become. Red Kowalski died in 1987, taking his secrets with him to a small cemetery in Hamtramck, Michigan. His obituary in the Detroit Free Press mentioned his service during World War II and his 40-year career as a machinist, but said nothing about the transmission innovations that had helped win the war. The few people who attended his funeral knew him as a quiet neighbor who kept his lawn neat and helped fix their cars when they broke down. But his legacy lived on in ways he never could have imagined. The principles he developed, hydraulic dampening, distributed torque loading, thermal management, became standard features in automotive transmissions. The automatic transmissions that made driving accessible to millions of Americans incorporated concepts that Red had pioneered in that condemned Sherman in Bay 7. Modern tank designers still study his modifications, marveling at the elegance of solutions developed with 1940s technology and wartime constraints. Military historians who have uncovered his story consider him one of the unsung heroes of World War II, a man whose innovations saved more lives than many famous generals. The lesson transcends warfare and speaks to the heart of human ingenuity. Innovation often emerges not from perfection, but from the wreckage of failure. Red Kowalski proved that one person's condemned machinery can become another's masterpiece, that genius lies not in creating something from nothing, but in seeing possibility where others see only scrap metal. His story reminds us that the most important battles are often fought not on famous battlefields, but in anonymous workshops by people whose names never make the history books. The war was won not just by the generals who planned the campaigns or the soldiers who fought the battles, but by the machinists and engineers who made sure the machines worked when they were needed most. In the end, the most powerful weapon isn't always the biggest gun or the thickest armor. Sometimes it's the quiet determination of someone who refuses to accept that anything is truly beyond repair, who sees opportunity in disaster and possibility in failure.